Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Okay, so we had a hiatus of a couple of weeks.
We did a little bit of COVID exposure scare, but
yes,
we are back.
We're still good, so
we're
that's
good.
Nice.
I did not get COVID, so
yeah,
thank goodness. My kids did not get COVID, but
right.
We're back.
And this week we want to talk about, I guess, when it makes sense to move forward. I guess it's language features, evolution of languages. when does it make sense to move forward?
Yeah.
And
so we're thinking about this in the context of Java first, and how Java has added a lot of language features over the last few years, maybe even last, let's say 5 years or something, starting with Java 8 and lambdas, or what do we call them in Java?
I think we still call them lambdas.
Yeah.
I should know, but I forget after I write it down in a book. It's like, it's in the book.
Yeah. And all the stream
stuff. Yeah.
And then modules in Java 9.
Well, I guess I'm now thinking in terms of the long-term releases, because I've now become suspicious of features in the intermediate releases because they seem like they're experimental features and they don't always make it to the long-term releases. That's my perception. I may be wrong.
I think on that they realized that they couldn't really get enough feedback on language feature changes unless it was an actual release.
That is my perception. So it's a little bit of a But anyway, that's how it works. So yeah, and modules, and like the uptake of modules isn't that great, and they didn't include versioning, and well, so my experience that kind of brought this up was I realized that I was been working on updating the Java 8 book, and I realized, I've got @ override in some places, but not everywhere, and I had to hunt through the book, and I know there are tools, but that's, anyway, so I went through and did that, and it felt like kind of a half feature.
Yeah.
And it's like, if you use it and remember to use it, then it can help you in some situations, but it's not like Kotlin's override, which you have to use.
Yeah.
And it just makes such a difference. And then I also, just this last week, I was working on, I had a mistake around object equivalence.
Yeah.
And I thought, this should only take a few hours to fix, and it's been days, and delving in, discovering all kinds of weird things about the way object equivalence works. And I assumed that in Java 9, you're with numbers, like you're not supposed, new integer and new float, new double, etc. Those are deprecated in Java 9 and beyond. And I thought, that's to fix the thing I'm looking at, which is the weird object equivalence thing. I posted the thing on Reddit, and somebody came back and they go, no, it's for efficiency. And I'm thinking, I have never seen.
So we're supposed to use primitives again?
No, we're supposed to use value of. And if you, for example, if you say
it's a static method on those.
It's integer.value of. And if you actually say integer x equals 11, it will translate that to a call to value of. But new integer 11 is apparently so inefficient. So what's weird about this is that
I've seen an unboxing overhead, or
it's the call to it's doing the normal new call, which you do with every other class in Java, except strings. It's all these special cases, but
doesn't it have to new an instance of it anyway?
No, it's using the value of and it does all kinds of things under the cover. In fact, the behavior is different if the number is in the range of minus 128 to 127.
If it's like it's a static pool of values.
Some sort of caching. And then if you're outside of that, the behavior is different. It's like, wow, all of this to just use numbers. But the thing that blew my mind was, because I assumed that, of course they're deprecating new integer for some, it's probably the reason I'm finding, because you have people having programming problems, but somebody on Reddit said, no, it's for efficiency. And I have never encountered anything that was deprecated for efficiency reasons.
Huh.
And that means that the efficiency has to be so terrible that they actually said, oh, we need to deprecate this. And I'm still kind of reeling from that, going, wow, I didn't know that was an option when it came to deprecation.
A constructor of a basic number type. That's
all of them, in fact, all of the boxed primitive, all the types that reflect primitive boxing. And I mean, it's, Kotlin, of course, removes all that. And then using the equals sign, don't use that. You have to use object. You have to use dot equals, except when you're using primitives, when equals actually does work. And it's like, oh, okay. And beginning programmers are supposed to understand this. And I mean, I wasn't aware of this.
Yeah.
And I mean, I don't even know when this became a thing. I feel like some earlier, like when I wrote Thinking in Java, I thought, okay, I've got this understood and, do it this way. But apparently I didn't understand it fully then.
Yeah.
And this is just numbers,
Yeah. Yeah. Just a pretty basic.
And it's like, oh, use primitives or use box things or use.
So like technology has to evolve, but it's a really hard thing to figure out. As you evolve it, you put a burden on your users to then have to come along with you. And I think that with all the new great stuff that's going into Java, people aren't adopting it. Like the vast majority of production stuff is still on Java 8. And even the stuff that has generally moved forward to newer Java
and how many people are using the Java 8 stuff?
Syntax.
Yeah.
Yeah, and then even a lot of the Java 8.
Are they using streams? Are they using lambdas? Those are new concepts,
I think there's a lot of Java programmers who aren't adopting those features even. Because, they're challenging. And so there's, and it's a huge impact to your code base. So if you have a legacy code base and you want to move to new language features, there's potentially a lot of things that need to be changed and rebuilt. Like to move from normal for loop stuff to the world of streams, that's a big change for people.
And you have to, streams are not, it's not as simple as just saying, oh, I'm using a stream now. You have to understand, there are trade-offs and things. You don't automatically get better performance just by.
Maybe you get worse performance in some cases.
Some cases you do.
The uncertainty of that, I'm
right?
Sure,
because you can put in a parallel, thinking, oh, well, this will make it run faster, and it can make it run slower.
Yeah.
And you have to understand those things, or else you get. Well, and we were also talking about Go's template or generics that they're adding.
Yeah.
And we were looking at the document, and it's got to be like in print form, 200 to 300 pages long, I would guess.
Significantly long.
I will say that it looks much more like a book than a spec. It's got lots of examples. It looks like it's like bringing people into it well. But, wow, that's a big change for Go.
Yeah, and in that example, I think that the usefulness of the language feature depends on the ecosystem adopting it. And so there can be a bit of a chicken and egg with these new features where for generics in Go to really be useful and take off, people have to adopt it, but people aren't going to adopt it until the ecosystem has adopted it. And so it just could take a long time and a lot of work. Well, also with Python from 2 to 3 and how long it took to move an ecosystem forward to the new stuff.
Which was not nearly, in my impression was not nearly as big of a change. It enabled bigger changes moving forward, but the change from 2 to 3 itself wasn't that huge, but it caused...
not as big as generics.
Oh my gosh, no. Not as big as generics. And I guess we were talking about this as like, if you're running a business, how important are new language features to you? And I would say conservatively, 90% of businesses, they're just going, we're just trying to create a thing to solve our problem. It's great
and what
that
we
you
have works.
what we have works, and we have programmers who understand it. And what is it going to cost us to move to that new feature, and what benefits are we going to get? And we were observing that probably those companies are going to benefit way more from process changes. I mean, there's still a lot of companies that are not using version control and testing, and
just kind of basic programming practices are a whole lot more impactful to these
hugely impactful.
organizations
Like if they're not
than
doing
a new language feature.
Yeah, yeah, I mean, and because they're not doing those things, they're not even ready for a new language feature. They're still thrashing around with,
null pointer exceptions.
yeah. Well, for example, I mean, that's the thing, and that is actually a good example because, I mean,
Java added optional and people aren't using it.
Well, they're not using it, and I don't know if with Java, does adding optional really? I mean, because you'd have to use it you'd have to just rewrite your code base and use it everywhere. When
the whole point of it is that it propagates that information throughout the call chain. So,
and it has to. Well, I mean, it's like it's like monads. It's the same thing. You have to use them everywhere for it to work, and
monads all the way down or no monads at all.
Kind of, yeah.
That's probably true with a lot of language features, like even generics in Go. It's like for it to really shine and show its value, it has to be everywhere.
And one of the things that was a real problem with Python was newer code and how it interacted with older code. And so I'm wondering, well, okay, if you start using generics in Go and you use an existing library, is that going to be a problem? I mean, maybe not.
It's the interim.
Maybe it'll be fine.
Like if you call a function and you've got something with generic information on it, you kind of expect to get that generic information back out.
Mm-hmm.
Does that happen? I don't know.
Yeah, I don't know. Maybe my guess is that, I don't know. Are they using erasure?
Right.
Are they taking the C++ approach where you actually keep the type information, the compiler knows it and can use it?
Yeah.
So
a startup idea.
Yes.
For our listeners, somebody should do this. Is we know that technology needs to evolve. At least I think it does. I like that technology evolves, and I like to stay up on the latest and continue to move forward. But for a lot of people, the investment in that is not really worth it. And so why can't we automate it? Why can't we have tooling that automates the migration to newer things for us? Take, for example, GitHub. We have a giant code base on GitHub that's public that you could diff and say, all right, this thing moved from this version to this version. Let's take a corpus of everything that changed when they made that particular change, and let's feed that into some AI system and start to build an intelligent AI from this corpus of GitHub changes.
We're just giving up and calling it AI now. Is that?
That's right. Yeah.
It's not intelligence, but we're not gonna use machine learning anymore.
I don't know.
Anyway, go ahead.
So couldn't we build a smart AI based on GitHub as a corpus that could help us migrate to newer things?
I've imagined some language that somebody's going to invent in the future. Well, and Kotlin has done this with IntelliJ. Like you can apparently click on a Java file and you can say convert it to Kotlin, and it's been getting better and better.
Yep.
But I could imagine somebody coming up with a language and they say, and we have the automation. We've designed the language around being able to do automatic conversion.
Yep.
And to me, that would allow it to take off so much faster.
Yeah.
Plus, the language would have to be really carefully designed.
Yeah. I think there are cases where you can't automate it. Like take, for example, the nullability optional one. If you took an existing Java code base that had no information about nullability in it, and you said, convert this to a null safe code base, it would just throw an optional everywhere. Like everything would become an optional. And that is
Wouldn't that still be better though? I mean, at least you'd have it laid out for you, and
Yeah.
you could change away from optional if you wanted to.
Yeah. Yeah.
Yeah. So, I mean, I feel like that would still be helpful.
Yeah.
It's just not as good as like actually doing a smart conversion, but you can't because the information isn't there
Yeah.
in the Java code. So.
Right. Yeah. Yeah. Because the things that you're calling aren't conveying optionality, then everything is optional.
Right. Yeah. I mean,
Everything
because it doesn't have the good enough compile time checking. It just says, well, we'll throw an exception if something goes wrong.
Right.
So it's all.
Yeah.
Yeah.
Yeah. So I could see challenges with it, but it feels like we got to have some way to evolve more easily, more fluidly, in a way that doesn't cost us so much, so that people can adopt new things. And because it's a huge
it's a refactoring though, and you have to have the tests in place to validate refactoring.
Yeah. Sometimes it doesn't feel like we're just in the Stone Ages with this.
We are. We are. I know people in the future. Okay, so this is going to sound weird, but sometimes I think, what if we're in a museum? It's in the future. We're in a museum and we're learning the history, the origins of computer programming. And like we go up to this machine and I don't know, we put our eye up to it or something like that. And in a fraction of a second, we're living our lives. So it's like you're experiencing the development of computer science through your experience. And both of us have, we have pretty interesting experiences. We meet lots of people who are, pioneers in the field, and we see these things and these struggles. And it's like, wouldn't that be a great way to learn the history of computer science? So, and then there wouldn't be any free will because we're just playing a tape. Anyway, that is deep, but that's way off the edges there. Anyway, but bring us back, James.
Yeah. So, I mean, if we were in the future looking back, it would be like, what? They didn't have tests? Like that was
they didn't even think about tests until this guy thought, hey, we should have tests. Kent Beck, I guess.
Memory management, like manual memory management, just seems like, why in the world would you ever?
I can answer that. It's because we came from assembly language where memory was so precious that you had to, and that's why we have vars instead of vals. It's because you got to reuse that memory. And so and the cultural change that it takes to get us thinking in this. I mean, it's just like the Java 8 streams and lambdas. I mean, that's a pretty deep change.
Yeah.
That's a real. I feel like I was only comfortable with it because Diane and I had written the Scala book, and so we had gotten our teeth into it, and then it didn't seem so weird. But for somebody who's coming from Java, a lambda, I mean, it's just a little nameless function with different syntax.
It took me a long time to kind of really wrap my head around it.
Mm-hmm. Right. And then, plus there's the confusion that's introduced by the languages themselves when they call them closures. Because having a closure is nothing to do with a lambda. It's just saying, this nested function can close over the surrounding variables. Well, it could be any function. It doesn't. Right. But then some of them just call them closures, and you're going, my God.
Yeah. I mean, I've been building a list of things that I think that we'll look back on and be like, yeah, that was a bad idea. Mutability being like one of the top ones. Builder patterns, of course. Exceptions. There's a few other things on my list. Back to memory management.
Well, I would say exceptions for everything, but go ahead.
Right. Yeah. Well, yeah.
I mean, exceptions, which the goal is recoverability, and most of the things that people throw them for are not recoverable. So it's a bad use of them.
Yeah. Back to memory management. I saw a great tweet this week that was like, C, also known as a domain-specific language for memory-based vulnerabilities or something along those lines. It was like, because there's just a vulnerability found in sudo. The of course was because of some buffer overflow or something, It's like, why are we why are we still managing this memory buffer sizes and stuff like on our own?
I guess I've
Manually.
met enough people who have, you know, the thing is, they're usually pretty smart, but they're still subject to the Dunning-Kruger effect. And I would say with things like that, low-level details, oh yeah, I can get it right. I used to program in assembly language, so I can figure that out.
Yeah.
I mean, like myself, I wrote a floating point math library in assembly language. I have no recollection of any of that,
Right.
but I know that I did it, and it's like, hey, I'm smart. I can do those things. And the other thing is concurrency, of course.
Yeah.
And I've met so many people when I try to say, you don't have the capability to do this. Do not try. Do whatever you can to guard yourself against. Yeah, it's like find the stud in the wall and anchor yourself to that. Um, and but they'll say, well, I know you don't think you can do it, but I can do it. And there's no talking them out of that.
No, I mean, yeah, I mean, there is this. Maybe as programmers, we have this ego complex around thinking that we can solve any problem. This came up recently for me because I started using yet another declarative workflow engine.
Oh, what's that?
In this case, it was GitHub Actions.
Oh yeah,
and so which are great, but it's YAML and it's declarative, and it reminded me of how I a few years ago had built, in my case, a JSON-based workflow engine. And I think we've talked about this a little bit on the podcast, but it reminded me how all of these declarative workflow languages just slippery slope towards a general purpose programming language, and mine certainly did. Like there was a point where I was starting to like implement JSON based Boolean logic, and I'm like, this is going too far. Like, why am I writing my own programming language? And so with that project, the Boolean logic, I was like the first moment when I realized, all right, I am sliding here, and it is not good. And why did I and so many other people go this route?
Well, let's just do the simple part, and that'll be fine. And then you just keep inching. My father used to call it inching, yeah. And then pretty much, and I know when it happened with Make, and they go, they're like, get up to the precipice, and they go, oh, we're trying to do that. And we don't want to do that. So we got to stop now.
Yeah. In my tweet about this, I was like, at the point where you have to start learning Lambda calculus to build your type system for your declarative workflow system, like that's the point, I think, when you like look over the precipice and are like, this has gone too far.
Mm-hmm. Yeah.
So with GitHub Actions, I discovered in the last few days as I was diving into GitHub Actions, but that they don't really have a good composability model, of course, because we didn't think about that up front. So GitHub Actions, it's hard to kind of compose code across them. Same is probably true for most homegrown workflow declarative languages, but an intern at GitHub started working on a way to do composability inside of GitHub Actions, with fancy YAML syntax. And I'm like, this has gone too far, people. Like step away from the cliff. Let's rethink this whole thing.
Maybe we need to take the approach that people would, I mean, basically TypeScript does this. They go, let's create another language that translates into that language.
Well, so one of the declarative workflow tools that I've used, which the language that actually you give the system to run is YAML, but they've created a Python language that then compiles the Python into the declarative YAML. But of course, like there's just limitations. Like the YAML is not Turing complete, whatever, and so they
constrain the Python,
what you can do in your Python. so that it's convertible to the YAML.
So it's basically a different language,
Yeah.
and that's another problem that I see. It's like people go, well, it's the same with Gradle. It was like, oh, we'll just create this declarative language and we'll build it on top of Groovy, but you won't really have to know Groovy. And if you do, then there's Groovy to solve your problems. But ultimately, now you have to learn this different language, whereas, maybe it would have been better. I mean, if I was doing a build tool for Java, I think I would probably try and use Java.
Right.
Because people already know Java. It's not, and Groovy is like Java, but it's different in so many other ways that you're learning a different language.
Java didn't have the DSL capabilities to make for a nice experience.
I think I would have gone the other direction and said, well, all right, let's do whatever we have to do to work within Java. Don't use a DSL or whatever. Just create.
But at least it would be Java.
It would be Java, so you wouldn't have to learn a different language.
Yeah. I guess I haven't really seen someone do this well, where it's like, all right, here's your nice DSL, and you really don't have to learn the underlying general purpose language. Like, that never happens, right? Like,
not in my experience, but I mean, I haven't looked at everyone out there, but it does. When Martin Fowler wrote his DSL book, there's a big, oh yeah, this is going to solve lots of problems. And it's kind of calmed down. And I wonder if it isn't because of exactly what you're talking about. It's because, oh yeah, it's the leaky abstraction thing. Again, it's like the abstraction is the DSL. And then it turns out that no, it's not.
Yeah.
It doesn't.
It's going to leak.
Mm-hmm.
And in the case of Scala, as I was learning Scala, there were so many times where, I was kind of working in like a DSL-y, usage of Scala, but there were so many times where I would get a compiler and I would be like, how do I understand this? And I couldn't. And so then it's like, all right, now I have to dive further into the general purpose language. The alternative that people have brought up in response to topics we've had around this on the show before is something like DAL is maybe a better approach, where you have not a general purpose language, you have a very constrained DSL, but at least like DAL has features that you normally need if you are doing workflowy type of things.
And presumably maybe IntelliJ would be able to help you with it. Right. It would be clear enough. It wouldn't.
I wonder if anybody has tried DAL for a workflow engine. That would be interesting to know. I'll have to look into that. Yeah, so it would be interesting to see like how this particular topic moves forward, because I think where we are today with all these different YAML-based workflow tools, it's not a good place. Like there is something fundamentally wrong with the approach that we've taken here, and there's got to be something better.
But okay, and the reason that we're YAML and TOML and whatever is because we had XML before and that was awful. And so by changing the syntax to be better, that was supposed to solve the problem. And you're saying, no, maybe the problem is declarative DSL approaches just are problematic.
Yeah. I mean, so composability, I think for me is a really big one, is that when I'm writing code, I build reusable pieces and I use libraries, which are reusable pieces. And that is a fundamental thing that I do all day, every day. And when you're in the world of most declarative systems, there isn't the ability to do that. Like, look at SQL. Like your reusability model in SQL is
cut and paste.
Which just makes me so sad. So I think that's a big one for me. Obviously, like the lack of type systems and the lack of schema definitions, like just hurts badly. Whenever I'm writing these, whenever I have to interact with one of these YAML-based declarative systems, my Git history is just like 100 commits that say try this, try this, try this, try this. It is a terrible, terrible way to test things and to validate that something works.
Now, so when I put up the Gradle post that, caused a bit of a ruckus, the reply from the person, Cedric, yeah,
not Cedric Booth,
no,
but the other,
yes, one of the things he said, which I wasn't aware of, which was, oh no, you're not supposed to do it this way. You're supposed to use plugins. Right?
Okay.
Yeah. And which I didn't know. Oh, you're supposed to use plugins for things. You're supposed to write your own plugins.
Oh, okay.
And I mean, isn't that supposed to be like a reuse thing? Or I mean, why would I write a plugin except for reuse? I mean, even for us, I mean, even for one of
case, a huge challenge in the case of Gradle is that if you need to hook into life cycle parts of the build and change things, you can do that right in your build, or you can write a plugin that hooks into those things. So the build tool has exposed both of those ways to do that. And when you should do which, I think my assumption is that you write a plugin if you want to share it with others. But maybe what Cedric was saying was that no, the plugin model gives you a better way to tap into those hooks and make those modifications.
This was the first time I had come across this way of thinking. And I'm not sure if he's thinking of it in terms of, well, it's just easier to organize your code that way, or if what you're saying is like, oh, well, it's nicer to know at this point in the life cycle, the plugin gets called and it does its thing. And I don't know.
There's more explicit life cycle kind of call chain.
It's just newer things. It's like, this is more information. My problem was that I kept wanting to go where they said, which is, oh, it's easy. You just do this and it's declarative and it works. And I kept thinking, oh, I must be doing it wrong because I'm not getting that experience. Yeah. And then when I finally realized the things that I put down in the blog post, then it's like, oh, I see. I have to learn way more to get it to work. And this is one of those things. It's like, oh, we're supposed to use plugins.
So as an example of this, in the world of Maven, the language that you write your build in is XML declarative.
Mm-hmm.
And
Ant was like that too.
Yeah.
Mm-hmm.
And you cannot hook into build modifications via that XML declarative approach. If you do want to hook into the lifecycle, you write a plugin. And that separation, it has trade-offs because it's kind of painful. It's like, okay, now I got to go into the world of building my own plugin
but at least that's why you're doing it.
Yeah.
You're hooking into the lifecycle steps.
It's pretty clear where the boundaries are.
Mm-hmm.
And when to use which. It's actually 100% clear because you just can't do things on the declarative side.
Mm-hmm.
So I guess that those constraints are really useful, but also are painful because when you need to write a plugin, it's like, oh God, now I got to go write a plugin. Like it's you don't really want to take that step. Usually, and I've done it, and like it turns out fine, but then it becomes. Well,
you're trying to solve a problem, which is to get your thing to build, and then it says, "Oh, you need to take a week and learn how to write plugins so that you can get this thing to happen,
and learn how to publish plugins and pull in those plugins and."
Right.
Yeah.
And you're going, but I made an estimate, and this is going to blow my estimate, and that whole estimation thing is another topic. But but I mean, that's what I have to get over, is because even though I have it's just my own schedule. It's just, but I had expectations that this was only going to take a few hours, and now it's going to take maybe a week, maybe longer. I don't know.
Yeah. Yeah.
And then I just have to relax and go, okay, I'm learning a new thing. This is fun.
Yeah.
And then it's okay. But first there's
sometimes the learning the new thing is not fun.
I know, but I have to tell myself I'm learning a new thing. It'll be fun in order to get myself to do it. Because otherwise I'm going, damn it, just work. It's like what we were struggling with last night with the SBT build. It's that was just
head pounding.
Yes. Well, I think we probably should have stopped sooner and gone to a higher authority.
Yeah, yeah. We should have.
Yeah.
If Josh Surratt was not on East Coast time, I
Uh-huh.
think I would have gone that route
Yeah.
earlier, but
Right.
I didn't want to ping
No.
him at 11 p.m. his time.
Mm-hmm. Mm-hmm.
Yeah, but as you know, I'm not very good at just like being like, okay, I'm gonna give up on this for a while.
Mm-mm.
I just keep
You need
pounding.
that little endorphin bump that you get by going, aha, got it working.
That's right.
Which I
Yeah.
totally understand. I mean,
Yeah, it feels really good when you get there.
yeah, it does.
But my head sure hurts.
Yeah, wow.
Slamming it into the wall.
Well, but I mean, there was no guidance. It was just like, oh, maybe if we do this, maybe if we do that. No,
yeah,
no, nothing that. Although we did.
That's one of the challenges back to the original conversation around adopting new things, is that when you are kind of the first one to try something, you don't have that guidance. You don't have the Stack Overflow posts. You don't have, and so I think that that's one of the kind of chicken and egg problems with language feature adoption, or maybe any new technology adoption, is that you just don't have the ecosystem to go to get your help. And so then your only thing you can do is go to the experts. And that's often,
they have limited
difficult.
Bandwidth.
Yeah, they have that. But will it scale?
There you go. And we're lucky because we often can reach the experts.
Right. Yeah.
Yeah.
Yeah. So that's certainly one of the challenges with moving things forward, is like, to move forward, a lot of times you need other people to move forward before you, and somebody's got to do it.
Mm-hmm.
And in a lot of cases, a lot of people have to do it so that there's sufficient answers on Stack Overflow.
When I started working with C++, I was at the University of Washington in the School of Oceanography, and we were going to use it to try and do cool math things for physicists. And to get the compiler, we actually had to contact Strustrup and ask him to send us a tape, because the internet wasn't fast enough, I guess, or something. Anyway, I mean, and we were on a backbone, anyway. And the way I ended up figuring things out was at looking at the output of CFront, which is what takes your C++ and converts it to C. And so I'm, looking over the C, trying to figure out, what is this virtual function thing? Why are we doing this? And just kind of going through and finally figuring out, oh, it's like calling a different function depending on the type. Oh, that's interesting. Well, I don't know how to design. Why would you, nobody knew how to design with this. It was, that was
just uncharted territory.
It was. And
no Bruce Eckel book to read to learn about it.
Yeah, it was. It was quite an adventure.
Yeah,
I mean, it was very interesting, but it was slow.
I guess that's why technology adoption takes longer than I hope, is that there's got to be like, the early people that, stumble through and talk to the experts, whatever, figure things out. And then, some people behind them that, pick up some of their things. And it's just like, to move ecosystems forward takes a lot of energy.
It's not really, I mean, I wouldn't even call it the ecosystem. I would call it the culture, because it's how do we think and talk about these things? I mean, we've had this, I feel like we're close to being able to explain monads to people easily. But think about what we had to do. We had to struggle with the ideas and then go, wait a minute, why are we doing this? And that was, to me, that was the breakthrough. It's like, oh, we're doing this so that we have composability. Ultimately, we want to be able to chain things together, and we don't want to have to do all of the error checking every time. But in the meantime, people were explaining this using burritos. And it's like, that was such a non-star. I mean, it was like, didn't tell me anything.
Right.
Just tell me you're packaging information together. It just and then passing it from function to function. Yeah. And it's like,
I guess that's part of the ecosystem thing, is that you need people to try to explain it in lots of different ways. and like emergent chaos theory,
Evolution.
yeah, evolution, like eventually, if something is important enough, it is going to emerge out of that and be a better way.
It's a combination of the environment and all of the various experiments that evolution is doing.
Yeah.
And it's like, oh, people understand this thing, and one of these things actually works with what they understand already.
Yeah.
And that's the one that succeeds.
Yeah, evolution is just so slow. It's just a really slow
physical
process.
Evolution is.
Even like
cultural evolution, which is memes.
Evolution, like, how do we accelerate it? How do we make this faster? Because I'm not happy with how slow technology adoption evolution.
I know.
Happening.
I know
it's to move faster.
It does. I mean, I've always felt this way. I've always been trying to reach into the future and go, okay, yeah, now we want this problem to be solved so that we can do this more powerful thing and not be wasting our time. This is why I have mixed feelings about Rust, is because it's like, it feels like it's going backwards to say, you got to do your own memory management, but you get super speed from it. And it's like, okay, for little tiny solutions, I'm fine. Python plugins, great. But I don't want to, I don't want to manage my own memory or any of that kind of stuff. And I'm always thinking, what, or this language that we've been talking about that's based on the idea of versions. What's it called?
Unison.
Unison. It's like, oh yeah, what, or even, I mean, in my study of organizational structures, figure out what are your it's the architecture thing. What are your fundamental concepts that you need to nail down? Everything else can vary around that, but you need to at least have versioning, for example, or generics have to be built in from the beginning, or any number of things have to be these fundamental concepts that we get built in, and then we're not going to go down a path and discover, oh gosh, Go really needs generics or else we're not going to be able to move ahead. Now we're going to have to backport them in, and it's going to maybe break code, or who knows.
And then you have to move your whole ecosystem.
Yes, you have all these people who've learned Go, and now there's Go with generics that they have to acquire, and a lot of them are not going to want to do that.
Yeah,
maybe they should have called it a different language and say, yeah, this. I guess for them it becomes a maintenance issue because they're going, we can't maintain Go and maintain this other thing.
Yeah. I guess that was the Python 2, Python 3 thing where they reached the point where they're like, okay, we got to make some fundamental changes here so that we can continue to move forward. And it's going to be painful and it's going to take a while because we got to move a whole ecosystem. But we have to do it if we want to continue moving.
And Python is close to one of the most popular languages in the world now, which I never expected.
Yeah.
But I don't know that would have happened without
Python 3.
Yeah. And I was talking to somebody the other day about like Ruby, and just like, I don't know, Ruby's just off my radar now. I guess there's plenty of
people still use it, but it doesn't seem like it's growing. It's not a growing language.
It's not my impression, no. Yeah. So, I think you have to.
Sometimes you gotta kind of fix the foundation, go back, and that can be painful.
Well, and ultimately it is about, not just money cost, but cost in general. It's like, how much of my time, especially as we are trying to build bigger and more complex systems, how much of my time does it take, especially when I'm going, oh, wait, should I use primitives? Should I use these other things? Is my comparisons going to work right?
Can I use a constructor for this thing?
Or do I have to call a value? Yeah, how do I do that? And it's like, so part of my brain is taken up by that, and that impacts my productivity. Yeah. And but my impression is that's the way Java is now and forever. I don't think they're ever going to fix that. Yeah. I think they see value of as the fix. Yeah. So if you really want to improve your productivity, you need to move to the next big version of Java, which is Kotlin.
Yeah.
And then And then you're not struggling with all of those things all the time.
Yeah.
Oh, wait, do I use equals here, or do I use dot equals? I'll go look that up,
Right.
rather than just programming ahead, going,
Yeah.
yeah, this all makes sense to me, and
Yeah.
I can continue. So that's a pretty big impact.
Yeah.
But if you're a company, you're working, things are working for you. What reason do you have to change?
Yeah, I did a Twitter survey a while back where I was like, all right, if you're like an enterprise Java developer, for you, why haven't you adopted Kotlin yet? And I gave some options. I don't remember what they all were, but one of the options, by far the most voted answer, was that they don't perceive enough value,
Mm-hmm.
and so that caused me to, like, for me, I'm like, oh, of course Kotlin has significant value over
Yeah,
Java.
but we delve into all of that stuff all the time, and
Yeah.
we have personal experience with the productivity. But when you're looking at it from the business standpoint, the other thing is how, we don't perceive enough value. What other information do they have? They have to guess at it. There's no, like, they have no guarantee. And as we had argued before, their value probably would be much greater improved in process and stuff like that.
Right.
So, and you come and go, oh, it has all these great features, and they go, how is this going to help my business?
Right.
Probably isn't.
Yeah.
It probably isn't.
Yeah, it's a really good way to think about it, because I'm right now I'm working on rebuilding the cloud.google.com/Kotlin page,
Mm-hmm.
and as part of that, I want to pitch, like, okay, if you're a Java developer, here's why you should be using Kotlin. And so the things I've been thinking about is like nullability, type inference, like, a lot of the immutability, like a lot of the things that I love about Kotlin. But I think when I say those things to most Java developers, they're like, eh.
Nullability, though, that would probably, Bill's experience when he was experimenting with Kotlin for his previous company was that was the hugest improvement, was that
even for, I think, a lot of Java developers, if a null pointer exception pops up in production, they don't care. It's not their problem. That's like the ops team has to deal with those, like, production null pointer exceptions, and
mm-hmm.
like the cost of dealing with nullability is significant to them, and the cost of a possible null pointer exception maybe in production is like maybe minimal. And if you're writing something that's like doing stock trades or financial stuff, then maybe that's not true. Maybe in that case you really don't want a null pointer exception to blow up a transaction or something. But
a lot of those companies, a lot of fintech companies are like using Python. Yeah. So who knows?
Yeah.
And if you put yourself, imagine yourself in the position of like the CEO of some small to medium sized company, and some, a couple of language wonks like you and me come and go, oh man, this is awesome, this is everything. How would they look to you? They would look like just
what goes through their mind is, how much am I going to need to spend to train my developers to learn this new thing? They're going to think about, as I hire new developers, it's going to be really hard because this is some new language for language wonks. They're going to think about, like, possible production issues that this is going to cause. Where they're balancing all this against, like,
I got a system that works now.
It works, and it's pretty easy to add new things to it if we need to. Like, it's all understandable, controllable. That illusion of control is big, and so I could see, the executives being like, no way.
And these guys are totally deep in their rabbit hole about, language features and how these things work. And they look very out of touch with the business at large, and for sure. And there are cases like when Yahoo was started, they used some kind of Lisp to create it. And apparently it was tremendously beneficial to do that. One of the guys became a VC investor, and Y Combinator, the guy who created Y Combinator, and he would talk about, we we decided Lisp was the good thing to use for this, and it had all kinds of benefits. But you really have to, I mean, it's an architecture thing again. You have to go, what kind of problems are we solving, and how is this or that technology going to make that easiest to flow and add into the future, and wow, that's a crapshoot in itself. It depends on who you're talking to, because somebody's going to say my favorite language is clearly the answer. It's called motivated reasoning. Are you familiar with the term?
No.
Okay, so motivated reasoning, it's pretty straightforward. It just means you have an underlying, so if somebody comes to me and says, how should I solve this problem? If I'm going to be involved, I'm going to say, probably the best choices would be Kotlin or Python, but that's because I want to program in those languages. Right. So I'm motivated to reach that conclusion. And it's pretty basic. It's just a bias.
Yeah. But certainly impacts a lot of how decisions are made, I'm sure.
Yes. Well, I mean, and we're not aware of it. Yeah. I mean, most of the time we're not aware of it. It's just like, well, in the back of your head, you're going, well, I want to use this language. And, if you don't, I'm going to go to some other company or something, or it's going to be painful for me or something. Yeah. And, I mean, I had one of my best consulting jobs was a company, and I think they were using Java, and they brought me to help them use Java better. And I ended up showing them how Python worked, and they switched over to Python. But it was because they liked it, and also most of them were not computer scientists. They were, they all had masters and PhDs in mathy things or other things, and so it was just a lot easier for them to go to. So it was a good choice. But I, if I had been a I don't know, Ruby wonk, I probably could have motivated them to Ruby's the best thing or something like that. Yeah. So, it's a
interesting. Well, back to our original thing. I don't know. I do think that generally we need to move faster and help people move faster into adopting new language features, new things, new approaches. But I don't know how to help with that acceleration.
This reminds me of looking at organizational structures. And, once you read Reinventing Organizations and you go, oh, it is possible to have a flat model. And then you think about, how would I change an existing company to use a flat model? I would go in and I would talk to the people who had spent their entire lives reaching the top of the pyramid and say, I want you to give up all of your power. Right. And they would say, what now? Yeah. And it wouldn't happen. And it doesn't. I mean, it's almost like the problems with Agile, because Agile is giving up power to, you're saying, okay, you get to make the business choices and we make the technical choices about this and things. And, if we're not going to make it in time, we'll say, choose which one of these features you want. And their whole life has been, I demand what I want and I get it. That when you're telling me I don't get everything that I want, I don't like that. Yeah. And so they push back. And that's why Agile hasn't really flourished everywhere, even if it makes everything more productive.
Right.
And so
you have to give up control.
You have to give up control. And I think we're kind of talking about a similar thing here. Mm-hmm. And so my conclusion was, if you want to create a flat organization, you have to that has to be in your foundational architecture, is that it's flat. And I wonder if the same isn't true with technology choices. It's like, if you're going to create this, you're not, I mean, it's the same thing that we've seen with languages trying to back bolt things on later. It's like, no, generics really needs to be in from the beginning. And, your attitude towards technology has to be established at the beginning. Is it, we're going to use all the best tools and do it right? Or is it, software is a liability and we're just going to treat it as whatever we can get away with? And not saying that that's not the right choice. Maybe what is it? The spreadsheet, the Microsoft Excel now has, lambdas that are whatever, Turing complete or something. I don't know. And it's like, maybe that's the right choice for some businesses. It's just not what you and I are not interested in those businesses. We're interested in the ones that go, we're pushing the envelope so much that we understand that technology is fundamental to what we do. And there's probably a bunch of business. I mean, it's hard for us to think that because we're going, no, it's going to affect you everywhere. So you really, even if you're making grocery store checkout software, you should be using the most powerful,
reactive and immutable, and
because it's going to, I guess the real pitch is it going to make their experience cheaper and faster and easier and stuff? And that's what's going to appeal. That's what's going to appeal to them, is the and
their business goals, and
and they don't want to hear down the road that, oh, if you had made this better choice at the beginning. They're going, no, just, it's software, make it work, fix it. We just want to add this one feature. Why is that so hard?